Hello everyone, welcome back. So now we're going to import the data in SOPs and cache it properly. And we need quite a bit of data apart from the points to import to store everything needed for the whitewater, as well as any other advanced techniques that we need to do. And we talked about the smoke sim that's happening inside the flip solver, and there is two fields that we need, volume fields that we need to import. One is an SDF called surface, and the other one is the velocity field. And we're going to create a DOP import fields. This is the same thing we use for smoke or anytime we want to import fields from DOPs. And we're going to set this to flip fluids. As you can see, it's importing the geometry data, the surface field, and a velocity field. This surface field is an SDF. That's how the smoke sim is happening. It's using an SDF internally. Let's drag this guy and let's copy this, and we need to import flip object 1. If we take a look now, see we have our sim happening. Let's hit play a couple more frames, and we need to store this to disk. So if we if we middle click, you see we have 680,000 points, and we have a surface field and we have a velocity field. And if we save this to disk currently, it's going to take quite a bit of disk space, and Houdini has a node that can compress this data, or all this data together, and pack it to reduce the disk size. And the node for that is called fluid compress. The default settings are good. We don't have to change anything except the particle separation. We're going to copy the current one and link it to the fluid, to the particle separation here, and that's the only settings we need to change. Now if we take a look at the result here, you can see it converted it into boxes. And what's happening is Houdini is storing sparse data. So if these points, for example, they share X amount of attributes, Houdini will only store the attribute once, the information of the attribute once, and then store the IDs for where those points, where the attribute is being shared. So if all these guys have the same color, the same velocity, same everything, it's going to store the attribute information once and then share the ID. Say, okay, all these guys, they have this attribute, all these guys, they have this attribute, and that's where the data, the sparse data, is coming from. You can see the visualization here as well indicates how it's grouping points together. The more variation we have, the more boxes we're going to see, and this is going to save and reduce the data quite a bit. It also converted these guys into VDBs volumes, and converted this Houdini volume, which is vel X, Y, and Z, into a vector field, and that's a VDB thing. So if all we have to do now is save this to disk. I'm gonna call this sim box v1. I'm gonna store 40 frames. Let's hit save, and then we're storing this packed information now to disk. To be able to visualize this, we have to use a different node that knows how to unpack this information, and this node is called particle fluid surface. Let's create a file node first, import this guy. So this is our sim. You can see it's just boxes at the moment, and we're going to create a particle fluid surface node. If we connect that, it's going to try and mesh the data right away, and that's what it is set to. We can use this in many different ways. One way I like to use it is to visualize the points only. So if we go here inside the convert to and change this to particles, it's not going to change, it's not going to mesh or convert this into a geometry. And there's this nice option here called visualize, which will allow us to create similar look. So we're basically remapping the velocity magnitude through this gradient. We can also use the vorticity, which is not available at the moment inside the solver, but we'll talk about that that later. So for now, I'm going to use the velocity, and this is how we can view our points. And that's pretty much it. This is the point visualization that we can use in the OpenGL render. And then if we want to mesh this, we can simply use the convert to method and make sure the particle separation is the same as here. And that's pretty much it. We have our surface, our geometry meshed, and it's inheriting all the attributes that are available. Another feature of this guy is the region, which can help reduce or speed up the process. So if we simply tell it to only work in this domain, which will help with converting fields and stuff like that. And we can simply link, let me cancel that. We can just link the same one from the original source here. Paste relative. And it also removed anything underneath, and that's what, because this is the only geometry that we need to render. We're not gonna render everything else. This is the most important part, and we don't have, if we need the rest of the geometry, we don't have to use this. And that's pretty much it for the imports. Now as for the caching, we're gonna write this to disk. As mesh. Let's hit save. And then the next step is to use the volume field and the surface field and the velocity to compute the whitewater source and run the whitewater source creation and then the whitewater sim. And we're gonna stop here. We're not gonna do the whitewater at the moment, and I want to explain how to use a different sourcing technique, where if we wanted to create a flooding or any other thing where we emit continuously from an object. So we'll continue that in the next video. Thank you guys for watching, and see you in a bit.